Hi everyone, my name is Robert Olson. I am the only member of my team, and I am doing real-time risk prediction analysis for Super Smash Bros. Melee. Most of you have probably already heard of the Super Smash Bros. Series in general, but there's a large subset of the community that still plays the GameCube version of this game, which is now over 15 years old. A lot of popularity of this game comes from the high-speed creative combos that are still innovating and surprising the community. However, something that gets overlooked is this moment. This is the moment where the player puts himself at high risk, and he loses a life for it. It's called losing the neutral game, and it's one of the most important things in Melee that's very hard to understand where and when you're putting yourself at risk. The goal of this project is to give players a chance to analyze gameplay to see what situations are and are not safe. The hardware used for this video was one Nintendo Wii, one very old Mac, and one cloud. The data flow starts with the Wii console, and it gets routed to a LAN where it's picked up by my old Mac, which has a Project Slippy TCP relay installed on it. Now, this is a community-driven tool that allows these recordings to be processed over the local area network, but it was never intended necessarily to be run over the wide area network, which is what I'm doing in my application. So after that, it gets taken to a cloud relay script, which sends it off to the cloud. And then that's through an Amazon API gateway. And then that Amazon API gateway takes it to AWS Lambda. The Lambda is responsible for converting this compact data and turning it into something that Amazon SageMaker can understand. Now, we've already trained up an agent, and that agent is responding to a SageMaker endpoint. And so Lambda communicates with that endpoint, and it's able to get the prediction data back and send it all the way back down the chain, all the way to Project Slippy, where it can max out my computer's CPU. So here's a video of it working, and something that I'm really happy with right off the bat is the lack of latency between the two recordings. The one up top right is the actual game, and bottom left is after it's going up through the entire cloud architecture, getting its risk report, and then coming back down. And then the two boxes that you see on my Mac screen are the predictions for the risk. So I'm quite happy with how quickly all of that actually happens. You know, it's not perfect synchronous like I thought it could have been in my naive first report, but it's pretty close, and I'm really happy about that. In my first implementation, I was calling the WebSocket 60 times per second. So in the original implementation, this was spinning up 60 lambdas per second. So I changed it to do a more batch-oriented call, where now it only calls a lambda once every 30 frames or twice a second. So now we're only having two lambdas running at the same time. It decreases overhead a bunch. It makes it so I don't have to worry so much about the order the frames are coming in. And when it gets back down to the other side, it increases latency slightly, but overall it makes things a lot less complicated. For the debugging on this, I pretty much exclusively used Amazon's Cloud Watch metrics. Those are really useful, especially for the Lambda, because it allowed me to get an insight into how many concurrent Lambdas I was using at a single time, how many calls I was making to these Lambdas. And I could also use that same tool to trace it all the way back through the Amazon API gateway. So something that was really fortunate about this architecture too is I was able to check with someone who gave a talk at AWS reInvent this last week when I was there in Vegas. And she told me about this whole batch-oriented processing idea, which I thought was really cool, especially since with Lambda, there's no limit to scalability, right? The limit is how deep your pockets are. And the limit on the API gateway is also how deep your pockets are, and same with the endpoint. So it's really cool because this application is so scalable and also not complicated. The bottleneck is potentially non-existent. The biggest bottleneck here is actually my local hardware, my Macintosh. So That's a lesson for next time, is to get something a little bit more powerful, because the game can't play while a screen capture is going on, and it glitches out. So that's definitely the biggest bottleneck there. Everything in the cloud is actually functioning spectacularly.